Now we'd like to look at solving formulas for variables. Sometimes when people are working with an equation a lot, say in the sciences or in business, they might be working with an equation a lot, and the equation might be set up in such a way that say if I'm in business, I might have something like interest I wish to investigate. And so I might have an equation that relates the amount of money I have at some point to the interest that is paid and how much money perhaps I'm investing. Well, if I have an equation like that, say something like, we'll put it over here in the corner, say something like A equals P times 1 plus RT, then, well, a lot of times maybe just A is what we're looking for. But at other times it may be the case that I want to do a whole series of evaluations where perhaps what I'd like to find out is the rate, and that might happen a lot in business. So the key idea would be, well, maybe I should solve my equation for R, which would make it a lot easier to, if I needed to do a whole bunch of repeated evaluations and figure out what R is. And that's really the motivation for doing things like this. We want to make sure this idea that's in bold here is really emphasized, that the solution will always look like this. We'll have whatever we have on one side. We'll do that problem in a minute, but we'll have x on one side, and the key idea on the right side is there can be no x's anywhere. So we'll have the variable we're looking for. In the case above, we would have r on one side, and then over here we can have anything could happen. However, we have no r's at all over there. No r's. So here's what we do in order to solve them. First, we would try to clear fractions on both sides, if there are any fractions, multiplying both sides by the LCD of the denominators like we've seen before. And then we would gather all the terms, if we need to, on one side of the equation, which have the variable in them, and all the terms on the other side, which do not have the variable in them. And then we might have to do something like combine like terms, and then finally, when we have the variable isolated with only its coefficient, perhaps something other than 1, we then would divide by the coefficient, whatever that would happen to be. Okay, now let's look at that equation where A equals P times 1 plus RT. Each of these is different, and so we know that we would like to, we'll say over here what we'd like to solve for. We'd like to solve for R. Okay, so solving for R. Well, R is inside that parenthesis. Now, a lot of times if these were numbers, we might think, hey, I will multiply the P through, in other words, distribute P on the right side. I could do that. It actually makes this a little harder, though. Could we think of another way that we could get rid of the P? So first we're trying to isolate at least the RT and get that alone. So so we were thinking of kind of undoing the right side. What has been done to R? And the first thing we would have to do if we were plugging things in is distribute through the P, perhaps. So we'd like to get rid of that P on the right side. One way we could do that is just divide both sides by P. So we'll say A over P is equal to P times 1 plus RT over P. And what is P over P? P over P is 1. So we simply have A over P is equal to 1 plus RT. All right. Then we're still trying to get term with the r in it all alone. So the next thing to do would be to get rid of this 1 here. So we'll say AP, so we'll subtract 1 from both sides. That's being added, so we'll subtract 1 from both sides. The quantity AP minus 1 is equal to 1 plus RT minus 1. And so on the right side we have isolated the term with the variable we're interested in, RT, and that has to equal A over P minus 1. So now, what do we need to do now? We want the r all alone, so we're going to divide both sides by t. So A over P minus 1, that's all over t, is equal to RT over t. So going back up over here, simplifying that as much as we can, A over P minus 1 over t is equal to, well, what's left on the right side, t's go away, so we just have r. Now we have solved for r. Notice here we have 1 r on this side, excuse me, and no r's over here on the left side. So we have solved for it. We could simplify this left side a little bit. We usually wouldn't leave it like that. That's called a complex fraction. If I could say dividing by t is the same as multiplying by 1 over t, so A over P minus 1 times 1 over t equals r. And I could leave it like that again, or I could distribute that 1 over t through, and I would get A over P t minus 1 over t equals r. And we have now successfully, really any of these last 3 steps have successfully solved for r. Here's an example of a slightly more difficult problem. There's actually a different step involved to solve this. The key to a problem like this says solve for y, ry plus d is equal to 4y minus 5. The key to this is, after simplifying, here we don't have to multiply both sides by anything to simplify, there's no distribution, but the key is, look at here, we have y in 2 places, and the coefficients of y are not something we could ever add or subtract from each other and simplify it. That one of them, coefficients, is actually an r there, and the other one is a 4. But we will still use the fundamental steps. We're going to try to get all the y's on one side and all of everything else on the other side. So to do that, we'll start off by taking ry plus d, and we're going to subtract ry from both sides. So equals 4y minus 5 minus ry. So over on the left side, we just have d left is equal to 4y minus 5 minus ry. Well, we want to get everything on the left side that it does not have a y in it, so the next step would be to add 5 to both sides. D plus 5 is equal to 4y minus 5 minus ry plus 5. Well, simplifying, d plus 5 is equal to 4y minus ry. Here's where the additional step comes in. We have to actually, on the right side, we have y in both terms, and so we have a common factor of y. We're going to use the distributive property in reverse. Remember the distributive property over here on the right? A times b plus c is equal to ab plus ac. We're going to go in this direction. We're going to go from right to left, and we're going to say, if we had a common factor of a over here on the right, we can rewrite that out in front of a parenthesis. That's what we're going to do here. we have a common factor of y, so we're going to rewrite that out in the parenthesis, in front of a parenthesis, and say inside the parenthesis then would be 4 minus r. On the left side we still have d plus 5. And what has that gotten us? The idea here is then we have something times y, and just like if we had 2 times y equals d plus 5, just as if we had that, we would divide both sides by 2. So in this case we're going to divide both sides by that whole quantity, 4 minus r. And so on the left side we've done that, and on the right side y times 4 minus r over 4 minus r. Well, that 4 minus r over 4 minus r is 1. So we are left with y is equal to d plus 5 over 4 minus r. And that is our solution. Note we have 1y over here, no y's on the left side. And in this particular case, there really isn't any other way except using this distributive property. Right here on these 2 steps, we use the distributive property going from the first one to the second one. There was no other real way to do that. We have to do that. Otherwise, we're never going to get all the y's on one side with only a 1 coefficient and no y's on the other side.